Hello friends and welcome to edupediaworld.com, your destination to online education. Friends, as from the past few sessions, we are discussing and learning the types of elements of the modern periodic table. So in this session also, we shall learn something new about the topic. As in the few sessions, we have covered the representative elements of the modern periodic table with the characteristics, features, and the types of representative elements present in the modern periodic table. Now we shall start with the transition element in this session. Friends, before starting with the transition element, let me give you a brief concept of the modern periodic table. As we all know that element can be arranged in the long form of periodic table, which was actually proposed by Mendeleev. Now it's a modern periodic table, as it contains 18 groups and 7 periods, and the periodic table is based on the increasing order of the atomic number and the electronic configuration of the element. Friends, the long form of periodic table can also be divided into 4 blocks, that is S block, P block, D block, and F block. This classification is based on the position of the valence electron in the element. For example, you can see here the sodium is a S block element because valence electron, that is a valence electronic configuration of sodium, is 3s1. Therefore, we can classify according to the blocks that first and second group is a part of S block, whereas 13 to 18 group elements are known as P block elements. Elements from 3rd to 12 group are commonly known as D block elements, that are the transition elements. Whereas 2 series in the bottom of the table, main table, we have the F block series. So friends, now let's understand the actual concept and the actual positioning of the transition elements, why they are called transition elements, why they are transition metals, why they are called D block elements, and what are the general characteristics of these elements. Let's find out. Friends, transition elements are also called transition metals or D block elements. Well, it has many names, but actual definition proposed by IUPAC is an element whose atom has a partially filled d subshell, or whose element gives rise to positive ion, that is a cation, with an incomplete d subshell. Or many other scientists also describe a transition element as any element in the D block of the periodic table which includes group 3 to group 12 on the periodic table are the transition elements. Now friends, let's understand one by one about the main concept of these elements. First, they are the D block elements, right? They are located in between S block and P block elements. Therefore, they are called the transition elements, as D block elements show a transition from metallic to non-metallic nature. In other words, they show a transition from most electropositive S block element to the least electropositive or most electronegative P block elements. So this is the reason why they are called transition elements, as maximum of the elements of the transition, that is a T block element, shows the metallic nature. So they are also called transition metals. Another name of the transition metal is a d block due to the presence of incomplete d subshell or valence shell filled in the n-1d orbital. The electronic configuration of these elements are n-1d, 1:10, ns12. Friends, these elements are also known for the variable oxidation states. We shall learn this concept in the future slides. Let's now understand the general characteristics of the transition elements. First, we shall understand the characteristics as the d block elements have been divided into 4 series. We call it first transition series, where it is a 3D subshell which is the incomplete. For the first row, we have second transition series with the 4D subshell, third transition series with the 5D subshell, incomplete is the 6D. Actually, fourth row is incomplete row, which is actually later on shifted to the lanthanide series and actinide series, and then they are called the F series. Now friends, let's understand the basic concept. First, as I told you, we have the variable oxidation state here, as they have 2 levels, lower oxidation state and we have a higher oxidation state. In lower we have NS12 and in a higher we have the D subshell, which is unfilled. So by the study of the electronic configuration of the transition metal, it is understood that the variable oxidation state can be formed as there are both Ns and N-1d electron in bonding. Friends, the participation of Ns electron in bonding leads to +2 oxidation state. As you can see here, S block can only fill 2 electrons, so we can have only +2 oxidation state here in the lower oxidation state, and in the higher oxidation state we can have +3, +4, +5, +6, etc. These oxidation state depends upon the nature of the combination of transition metals with other element. As the oxidation state increases with increase in atomic number, we shall write that the oxidation state increase with atomic number. Now let's understand the magnetic property. Friends, according to the electronic configuration of the transition metals, it is said that they are generally contain one or more unpaired electrons, so they behave as a paramagnetic substance. These substances are attracted by the magnetic field, so as the paired electron will be repelling to each other and the unpaired will have the magnetic property in it. So these substances who have the paramagnetic character increase as the number of unpaired electron increases. So we can write here the magnetic property increase with increase in unpaired electrons. Similarly, we have the metallic character. Most of the transition elements of the first row form the metallic bonds. You can write So they form the metallic bond due to the presence of incomplete outermost energy levels. So all the transition element exhibits metallic nature. That's why they are called the transition metals. Next we have the ionization energy. As friends, ionization energy for the first row element gradually increase with increase in atomic number, and the ionization energy of the zinc is very high in the first row than all other metals, which is due to its fully filled d orbital, and third ionization energy of manganese is very high than any other. Last but not the least, we shall take the example of the main character, that is the atomic radii. Friends, in the transition elements, the atomic radii first decreases, then goes stable, and then gradually increases. Why is this happening? It is due to the screening effect of the unpaired electrons. This concept we shall study in the higher standards. Just for your information, just you should remember that the atomic radii is not increasing as atomic number is increasing. It first decreases, then keeps on stabilizing, and then keeps on increasing. So friends, here I end up with the main characteristics of the transition elements. I hope you have understood the concept of transition elements, which are the d block elements. Let's come to the main page. So friends, in next session we shall learn the inner transition elements, which are the F block elements. They are also called transition elements just because they are earlier kept into the transition elements. Now they are being separated and kept at the bottom of the main table with the lanthanides and actinide series. So let's understand all these concepts in the next session. Thank you.